for the last problem, and let's do something we haven't done. We've done circle, we've done square, we did two right triangles, now we did what? Cone?
Cone.
So I'm just scanning over here, and I notice number 12 looks good. It's just something different. And everyone, after I do this problem, would you remind me, because we'll be able to get out, if anybody's like because our test isn't until what?
Tuesday.
Tuesday. So we'll be able to wrap up related rates tomorrow, do a couple more of these problems. So Monday's basically gonna be mostly what? Just review, questions from everyone. If you're like, yeah, but I've done every textbook problem. I've done your entire chain rule worksheet, right? And you want more, I've made more practice problems, all right? So that's why I'll make sure that anybody in here, and Sarai asked me about these, so I'll make sure to give her a copy of this as well. And there's a bunch in here. And of course, you're probably gonna want the answers, so I'll put the answers in Canvas. Everyone looks at that. I won't print those out, but if everyone wants to work those, you can put them in Canvas. So this is number 12, Aaron. They call it a snowball. All right, so that's what?
Sphere.
That's sphere. Do y'all agree?
Mm-hmm.
All right, a snowball melts but then they say its surface area decreases at a rate of 1 centimeter squared per minute. All right, so and here we go. Snowball melts. So what is happening to the surface area and the volume?
Decreasing.
Decreasing, good. And you want to draw a sphere, you can here. It's melting. And what they said was, surface area decreases how fast? At a rate of 1
Centimeters square per minute.
centimeter squared per minute. All right, last problem. What's their question now? What are they asking? Find the rate at which the diameter decreases when the diameter is 10 centimeters. So what are we looking for? How fast the
Diameter is decreasing.
diameter decreases?
So the initial diameter is 10 centimeter, right?
That's right. I'm going to go off to the side here before I forget. Is diameter equal to 2r or is r equal to 2d?
R equals to
D equals what?
D equals to R over
Is
2R.
that right?
Mhm.
Before I forget. Because you know as well as I do, most of these formulas are written in terms of radius, aren't they?
Mhm.
Give me the area of a circle again. Pi
Pi R square.
r squared. Oh, it's written in terms of r, isn't it? Anybody know the circumference of a circle?
2 pi R.
2 pi r.
Or pi D.
Now a lot of you say pi d, but a lot of times everything's written in r's. This problem talked about how fast the what? Diameter is changing, so before I get started, I'm just going to put that off to the side to know, oh yeah, diameter is twice radius. Okay? Now, how fast diameter changing decreases? Find a rate at which the diameter decreases when the diameter is 10 centimeters. Okay. The only way I can work this problem is if I know the surface area of a sphere formula, right? So if you're like, well, I don't know it, don't worry.
4
I'll
pi
put it
R
down
square.
right now. Here we go. First of all, I want you to know volume. So this is volume of a sphere. We didn't need it for this problem, but I thought it's good to know. That is volume of a sphere. 4/3 pi r cubed. Oh, please feel free to ask me right for a test if you're like, I have trouble remembering the volume of a sphere formula. You know, just meaning you go, is volume of a sphere going to be out? Yeah, I'll give you a heads up. Cool. Yeah. Now, you know what's cool? The surface area formula.
4 pi R square,
If
right?
you don't want to memorize another formula, did you know if you just differentiate that with respect to r, you'll figure out the surface area of a sphere formula? So let's do it. Makes it an easy way to remember surface area of a sphere, right?
Mhm.
Just differentiate that, you'll know the surface area of a sphere. Try it. Let's have you go.
Right there.
3 times 4/3.
So that's 4.
There it is. So that's where I'm starting my problem, everyone. S equals 4 pi r squared. Isn't that cool?
Mm-hmm.
Did you know this works with the circle too? Watch. What's the area of a circle?
Pi R square.
Would you all differentiate that with respect to r? You'll get circumference. Isn't that cool? Isn't that neat? I know. The only thing is now you got to figure out what other geometric figures this works on. Works on volume for surface area. All right, now we're gonna differentiate this with respect to time, right? All right? You go, hold up, this is what I was thinking, everyone. We can do it and stuff, but didn't they say something about how fast the what? My goodness, I think they asked about diameter. You and I, before we start, can we put this in terms of date? So it'd be just like that volume over cone thing, because they asked about diameter, before we start, what can I substitute here? Now be careful, is it 2D or D over 2?
D over 2.
Yeah, look here. What would R equal? There you go. So I'm gonna take this. Because the question said mention diameter, let's put that at the beginning. 4 pi D over 2 squared gives me, ooh, I like it. Maybe that's easier to remember. What do you remember? What is
Pi
it?
D square.
Ooh, I like that. I didn't know that. I should know that. Pi D squared, that's an easier way to remember that formula. I want the surface area of a sphere. Surface area of a basketball. Pi D squared. It's just pi D squared. All right. Now we're going to differentiate that with ds dt.
ds dt equals to 2 pi d
2 pi d.
over dt.
And what do I write right next to it?
dd over dt.
Oh, this is going to look funny, huh? d dt. Everyone, if you want to make this like a delta, like that, for diameter, so I'll write d dt. So it doesn't bug you?
Oh,
That work?
then why is it DS?
It's the
Oh.
surface.
Differentiate that with respect to time, differentiate this with respect to time. Right? Didn't we always do that? Didn't we do it with the area of a circle?
Yeah.
Didn't we do it with the cone? We did dv/dt. We did it with the triangle every time. We d8 everything with respect to t. So we got to hit both sides of that equation every time with respect to a t every time. Now, where's this 1 go?
The surface area is decreasing, right? So that's it here.
And is it positive or negative?
Negative.
Man, you're good. Everyone agree? Look, Nick. Decrease. 2 pi. I don't know this thing, but
Only the
what was
diameter.
this number they said?
10.
Remember they said when it was 10?
Uh-huh.
Put a 10 there. What's the answer? Negative 1 over 25. What were the units? Centimeters per minute? Does that agree? Just extra practice. These are extra practice. Great question. I love it. Before I keep passing these out. She goes, I thought this was centimeters squared per minute. Josephine, think about what you and I were solving for. They gave us this, which was centimeters squared. The question said about this snowball, they said, find the rate at which the diameter decreases. A diameter, right, is not three-dimensional. A diameter, right, it's just this 1 unit length. So we're not doing unit squared or unit cubed, just gonna be centimeters. So a lot of times you gotta think about it when you're very at the end, you go, wait, what are the units here? She wanted to know this one problem, that's Sarah, and tell her one I thought she'd have fun with, the problem, tell her it was that one. Yeah. Yeah, tell her that one. There you go. Everyone, tomorrow we'll continue with related rates. Once we wrap that up, and I love that problem. Thanks for bringing that up. See any others like that, let me know. Hey, what are we gonna do Monday?
Review.
Second. Say anything you want. Anything. It could be these. It could be textbooks, right? It's all right. Thank you.
Alex? You're for Alex? That's for Alex?
Yeah, because I thought the DD would look weird. So I just wanted to change it to something. Yeah. Do you mind writing DDDT? Oh, she doesn't write. I was thinking about, maybe I should have just capitalized.
No, he wrote down the answer.
Yeah, maybe I should just done like D. Are you okay with all this? Wait.
Because I thought it was a 5.
Let me pass these out, I'll help you.
I don't like to.
There you go. There you go.
Where is it?
Some extra crack.
Actually, I think I do.
Just some extra crack. I put the answers in Canvas. All right. I gotta help her. Right?
You were asking?
You're asking for ellipse?
No, it just depends.
Yeah, but they need some answers.
Oh,
Oh,
They give it the other. I promise. It's in the box. At the very end of the question, they go, blah, 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 blah.
all right, buddy, take it easy, man.
Yeah. That's it. That's exactly right.
All right, Courtney, see ya.
Yeah, but they make it all sound confusing. And when in doubt, just think of derivative. If they said, look at the word, instantaneous rate of change, that means derivative.
No, 3
no, he
Don't,
skipped it.
don't think though,
Yeah.
like I didn't want you to get hooked on this. This is the danger of this thing. Don't let this stress you out. Like, oh, this one's on the test kind of thing. It's just, it's more about get the brain going, and it can't hurt you, it can only help. Look, we did related rates today.
Yeah.
I bet you I find one, watch. Look at this. A railroad track, we'll have to do this one more. A railroad track hits cross right angles, reverse down and.
See you later on.
Blah, 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 how fast, blah, blah, blah. So it's a right triangle problem. Cause you got the train going like this, related rates. Don't let it